Yeah, good morning everyone. So in the last videos, we had a very clear discussion up to, of course, we had some incomplete implementation is there for which program DQ implementation by using arrays. Okay, DQ implementation by using arrays we are seeing in that. One second, one second, one second. Yes. So we have taken up to which method implementation we finished. You can see here TQ arrays constructor we have seen. So next and after that insert at front. So how you can able to add an object at beginning, how you can able to add at the beginning, so how you can able to add at the ending. Okay, insert at the front, insert at the rear, and how you can able to insert from I mean how you can able to delete from front. So now we need to see how you can able to delete at rear, how you can able to delete at rear, because we need to delete from the ending, right? So that we are going to explain in this method. Okay, listen carefully. Sir, here delete at a rear, delete at a rear. Suppose if your front is double equal to -1, then what is the meaning? My queue is empty, right? I am printing the message saying dq is empty. So immediately return, because I can't add the objects, I can't remove the objects. So otherwise, what will happen? System dot out dot println of, we know the deleted object is, the deleted object is nothing but plus. So what is the object that we have deleted? DQ of French. Okay, so next again we are checking, is my front and rear both are pointing to the same? If it is the same, front is equal to rear is equal to -1 to make our queue as a beginning. Okay, so otherwise what we have to do, few more operations we need to do. If your rear is equal to 0, if your rear is equal to 0, then rear will become size -1. Okay, so else your rear will become rear -1. So this is nothing but how you can able to delete from rear. Anyway, I will take one example and I will show you how it is going to work. So in this also I'm going to take two cases. Okay, so consider my queue size is nothing but it can able to hold four objects: 0th location, first location, second location, and third location. Like this we have. So another queue is there in this state: 0, 1, 2, 3. Like this we have. So here, if you insert the objects, consider it is 11, it is 12, 13, 14, 15. Sir, here front is pointing here and rear is pointing here. This is one case. Another case, consider I want to insert the objects keep on in the front. So what will happen? So first it is going to insert here. So then it will insert here. Then it will insert here. So then it will insert here. Okay, so this will become your rear and this will become your front. Okay, like this we have, because we are keep on incrementing. In this case, this is the first inserted element, this is the second inserted element, this is the third inserted element, this is the fourth inserted element. But in this case, this is the first inserted element, second inserted element, so third inserted element, fourth inserted element, because in this case I followed insertion at ending, insertion at rear, but in this case I followed insertion at the front. That's why the locations are different. Now observe carefully, I want to delete from rear. Is your front is equal to -1? In both cases, the condition is false. Then deleted item is q of friend. So here the deleted item is 11, and here the deleted item is nothing but sorry, q of I think you need to take a rare, right? Because we are deleting the object from rare. So what is the object that we have deleted here? 14 is the object. So here 11 is the object. Okay. Now, so in this case, is front and rear both are same? No. If rear is equal to 0, no, it is not equal to 0. Rear will become rear minus 1. So your rear is pointing here so that this object got deleted. But in this case, sorry, is front and rear both are same? No. Is rear is equal to 0? Yes. Then rear is equal to size minus 1. Now your rear is pointing here and this will be deleted. That's all. Like this we are going to perform. Okay. So I think you people got clarity about the deletion from the rear, sir. Can you please confirm, is the concept is clear for everyone? I request everyone to please respond. Clear up to this? I request everyone to please respond. Yeah. Now, sir, coming to display function. In display function also, I have two cases are there. Let us talk about those cases. Suppose if your friend is double equal to -1, then what is the meaning? My DQ is empty, right? System dot out dot println of I am printing. So DQ is empty. Okay. Then return. One second, one second. Please wait. Yes. So if a friend is equal to -1, then my DQ is empty. Okay. Sir, now what we have to do? You need to take two extra variables. One is nothing but left, which is pointing to front, and another one is nothing but right, which is pointed by rear. So there are two cases are there. One case is nothing but if left is less than or equal to right, what will happen? So if left is greater than or equal to right, what will happen? Right. So here I am taking two cases, the same example, whatever example I have taken in the previous case, same example I am taking. So this is nothing but 0th location. So this is the first location. So this is the second location. This is the third location. So this is the 0th location. This is the first location. This is the second location. This is the third location. So here 11, so 12, 13, 14. This is nothing but front what we have, and this is nothing but rear what we have. And here this is nothing but front what we have. Sorry, I think this is, so this is nothing but 11. So 22, 11 first inserted item, second inserted item, so third inserted item, fourth inserted item, like this we have, and this will become rear and this will become front, like this we have you observed here? You can able to check, sir, left is equal to front, right is equal to rear. Sir, is your 0 is less than or equal to 3? Yes. Then one case. So this right is nothing but this one, left is nothing but this one. So is left is less than or equal to right? No. Then one case. Have you observed two special cases are there? So that's why if left is less than or equal to right, one case. If left is not less than or equal to right, one case. So if left is less than or equal to right, so what we have to take? While your left is less than or equal to right, so I'm going to print keep on the elements like system dot out dot println of dq of I'm taking left plus plus. Okay, left plus plus followed by space. Sir, what will happen? It is keep on printing the items. Sir, first time dq of left. So dq of it is going to print left means what? 0. So that is nothing but 11. So then dq of left plus plus, your left will point to 1. So that means 12. Next left will point to this one. It will print 13. Left will point to here. It will print 14. So left will point to next other element, but this condition is failed. It will come out from this like this. Sir, if left is not less than or equal to right, then what will happen? We have to write two loops. The first loop is nothing but until your left is less than or equal to your size minus 1. So you have to print keep on the elements. Okay. So dq of I am taking left plus plus. Like this we have to print. Up to how many elements? Until your left is less than or equal to right. Now you can see here my left is 1, right? So is 1 is less than or equal to size minus 1. Size is 4. 4 minus 1 means 3. Is 1 is less than or equal to 3? Yes. Then print this element. Next left plus plus. Here we have. So is 2 is less than or equal to 3? Yes. Then print this. So is 3 is less than or equal to 3? Yes. Then print this. Sir, is 4 is less than or equal to 3? No. Okay, so it will come out from this, sir. But still we have one more element is there, right? How you can access that? Right. So like this we have. Sir, this pending element, how you can able to print? So that's why we have to write one more loop for this purpose. What is that loop? Make your left to 0. Okay. So while your left is not equal to right. Okay, while your left is not equal to right, or your left is less than or equal to right, you need to keep printing the remaining elements. System dot out dot print of, so dq of left plus plus, so followed by space. Have a look once. So left is equal to 0. Okay, is 0 is less than or equal to right? No, here left is nothing but 0, less than or equal to right. It is nothing but 0. Condition true. Then what will happen? We are printing dq of left plus plus dq of 0. Sir, like this we have to print. Okay. Sir, left plus plus 1 is less than or equal to 0. Condition not satisfied. This is nothing but what we have. Okay, sir, after coming out from this, so we have to print empty line to avoid next time confusion. Okay, because here we are printing print and then print and then print, right? So that's why after printing out from this, just I am printing one empty space here. This is the way how you can able to display the objects so present in that DQ. Can you please confirm? Is this technique, is it clear for everyone? Yes, please confirm. I request everyone to please respond. Sir, everything is okay. Now we have to run the program. What is the class name that we have given? DQ arrays. So first we need to create object for DQ. DQ is equal to new DQ or new DQ. So Q dot, I want to display the objects. So Java C test dot Java. Sorry, I think here we have taken DQ. So you can see we are getting the output saying DQ is empty because we don't have any elements, right? So now I want to insert. Sir, please listen carefully. Insert at rare. Insert at rare. That means it will add this object at the ending, sir. Now you are going to get a triple one as the result. Whether it is a front or rare, only one element is there. That's why we can't show any impact on this. Now my requirement is I want to take a triple two here. So where it will be added? At the ending, right? Because we are performing insert at ending. Now I want to insert one more object like triple three. So where this object will be inserted? Like this, it is going to be inserted. If you want, you can cross check. Okay, like this we have. So now my requirement is I want to add at front, sir. Okay, I want to add at front. Let us see how you can able to work with this. So DQ dot, so insert at front, insert at front of, I am taking, so 777. So where it has to be inserted? Front in the sense here only, right? So now let us cross check. Yes. Now I am adding 888 where this 888 is inserted like this. Have you observed? Q is full. Q is full because we have fixed the capacity as 5 elements right in the very beginning. So that's why we can't able to add the new objects into this. Sir, can I delete? Can I delete? Yes. System dot out dot, otherwise directly we can call because it is not returning anything. So insert from front like this I am taking. So the item which is inserted is nothing but 888 and this object got removed. Now you, sorry, one second. Delete, right? You can able to see deleted item is 888. Deleted item is nothing but 888. Like this we have. Sir, can I delete one more item? DQ dot. So delete from, like this we have. Now what will be the output? 777, 111, 222. That's all. Okay. So you can able to see, sir, insertion at front is working. Deletion at front is working. Insertion from rear is working. Deletion from rear is also working. I think you people got clarity about complete information about DQ is very clear for you. I think so, right? Any doubt in this DQ implementation by using arrays concept? Please confirm. Is it clear, right? right? So now my requirement is I want to implement. So DQ implementation by using linked list. Okay. DQ implementation by using linked list. So how you can able to implement DQ by using linked list, we are going to see now. Okay, it is a very simple, right? So we have to represent in the form of linked list, means same insert at beginning, insert at ending. Like that, we have seen some functions in the linked list, right? Same concept. So I'm going to take DQ. Okay, so DQ by using list. DQ by using list. Sir, what are the required entities? Node I need friend. Okay, so node I need to take a rare. Next integer, how many elements are there? Of course, not how many elements. Better you can take it as a count. Okay, so which indicates the number of elements, not a maximum number of elements. Okay, then I'm taking DQ. Okay, DQ list, I'm taking a constructor. In this constructor, I'm assigning friend is equal to null, and then I'm going to assign rare is equal to null, and then I'm going to initialize count is equal to 0. So next we need to define that node, right? Class, I'm going to take a node. In this node, so I need to maintain, one is for storing the data, another one is nothing but next field, which is pointing to the next node. And we need to take a constructor which will take the data at the same time node next, like this we have. Okay, so what is our next requirement? This dot data is equal to data, and this dot next will become next, like this we have. Okay, this is nothing but node what we have, sir. So just I have prepared a structure for this, like DQ. If you want to implement this DQ in linked list, so what pointers are required? Front and rear. Front will always pointing at beginning, rear will always pointing at ending. Whenever you are creating a new DQ object, so how these initial values are going to be taken? And if you take a node class, so what is the structure of the node? Data field and the next field, how these things are going to be pointed, I explained, sir. This is nothing but what we have here. Okay, so now what is my next requirement? We need to add the functionalities, like insert at front, so insert at rate, delete from front, delete at rear, and a display function. But before moving to this, can you please confirm, is the structure is clear for you people, guys? Please confirm. Is it clear for everyone? Please confirm. But what is count? Count is going to represent how many nodes are there in my linked list in my DQ. So same thing like sizes are, but if I take size, then you people are going to feel that is nothing but maximum elements that it can able to hold, like that. That's why I have represented as a count. Okay, better you can represent as a size. That will be good. Hmm? Now, so what are the functions that we need to take? Easy functions only. So one by one, I am representing. First one is what? Insert at a front. Sir, I have some node is there. I have some value is there. I have some data is there. I need to insert this data at very front. Suppose first we need to create the node, right? Because we don't have any exceptions here. Because so any number of nodes we can insert in the linked list. That's why node, new node will become, so new node of with this data and the next field is null. Suppose if your front is equal to null, then what is the meaning? That list is empty, right? In such cases, what we have to do? So your front will become new node and your rear will become new node, and then we have to perform size plus plus. We have to increment and then return. So this will happen when if there is no nodes in your linked list, that is TQ. Suppose if some content is already there, then your new node is there, right? its next field is pointed by friend, and your friend will become new node. Anyway, I will show you how it is going to work. Sir, it is very simple only. So consider I have initially my friend is equal to null. Okay, and so my rear is pointing to null. Like this, we have friend and rear are pointing to null. So I want to insert a node, that is the first node, right? Same like adding friend. Yes, yes, correct, Vishal. So now I need to add. So I'm creating a new node. This will become a new node. So with the next field as a null, this field as a 11. So this will become new node, right? So my friend is equal to null because initially we don't have any elements. So your friend will become this node, and your rear will become this node, and count, that is nothing but a size, will become 0 to 1. Sir, already I have one node. Just now I have inserted. This value will become 11, and the next field is null. So both the front and rear, both are pointing to the same, sir. Then in such cases, what we have to do? Sir, this is the newly created node what I have. Okay, but where we have to create insert at a front, right? That's why, sir, a new node is created here. This will become, so new node, next field is null. Consider the data is 22. This is the new node, right? Its next field is pointing to front, so this next field is pointing to front, and front will become new node. This will become front, and this will be gone. Okay, like that, insert at the front is going to work. Of course, basic terminology, sir. Can you please confirm, do you have any doubt on this insert at the first function? Everyone, can you please confirm, do you have any doubt on this insert at first? I request everyone to please respond. Clear? Right, sir. So now I need to insert the data at ending, sir. So for that, we need to take another function like void insert at rear. Insert at rear. So same, we have to take the data and we need to insert. So node, new node will become, okay, I am going to create a new node with the data field, and the next field is pointing to null. So if your front is equal to null, same case, right? That means we don't have any nodes. Then your front will become new node, and your rear is will become new node, and then we have to increment the size by 1 unit. Otherwise we have to return. I think here also we need to write a size plus plus one more time, because if it is returned, the control won't execute right after that. So that's why, so if that first case is fail, remaining cases we need to execute. Okay, sir, here the situation is very dangerous because, see, insert at beginning is very easy. Just we have to insert, we need to make next field to the next, right? So, but what about insert at last? Sir, already I have some node is there. Like this we have. Sir, now what is the next one that we have here? Sir, I need to create another node. So this is nothing but new node what I have. This is nothing but new node what I have. I need to link these two, right? So how you can able to link? Very simple. So rear tends to next will become new node, right? Rear will become new node. So then what is the next one? Rear tends to next is equal to new node. Then rear will become new node. Like this we have to take. So your rear is there, right? Its next node will become, okay, rear tends to next will become new node, and after that your rare will become new node. Like this you need to take, and then size plus plus. So very simple. Sir, I want to insert one more object. Sir, where we are going to insert? So here we are going to insert. Let us consider next field is null and the content is 33. So this is nothing but new node what we have. Sir, rare tends to next will become this one and rare will be pointing to here. That's all right. These are two simple instructions. Okay. So I think insert at the ending also clear for you people. I think so, right? Can you please confirm? Do you have any doubts up to this? Everyone, please confirm. Right. So the next one, what we have, I need to perform delete operation. So delete at a front. We need to write delete at a front. So we need to implement this. And even we have to perform delete at rare. How you can able to insert delete at rare. And even we have to see how display function is going to work. So these functions we have to implement, sir. Okay. So anyway, we will talk about these functions in the next session. Okay. Tomorrow we will meet for the continuation. Clear? Right, sir. I will upload the running notes within few minutes. You can able to download. Okay. Right, sir. Thank you.